Hello and welcome to the channel again. So I've got this amp on here. If you look on there it says Matchless, but this amp is actually not a Matchless. This amp is it pronounced Ceriatone or Ceriatone? It's a kit. And we're going to take a look at this amp and have a look inside, see how it's built, see what's in it, whatever. So let's have a look at what we've got on the front. We've got volume, bass, treble as one channel, and volume, tone, cut and master on the other channel. Very basic amplifier. Master volume doesn't work apparently according to the customer, so we need to wire that up. He bought the amp with that not working. So yes, not much to see really on there. Let's have a look at the back. This is one seriously heavy amplifier, so it must have some iron in it. Either that or I need to start going to the gym, or both. So we've got speaker phase, normal or reverse. Well, that's interesting. Loudspeakers there, power high, power low, so it must have some kind of attenuation on there. Only a choice of 8 or 16 ohms. Got a big nice toggle switch for that. Looks to me like this is running on EL84s, 6B Q5s. Let's have this back off and we can have a nosy inside. Right, so if we look inside, we've got JJs, and they look like they've had a bit of heat, not massive, but they've had a little. But then again, they could have been in there a long time as well. We've got GZ34 JJ as well going on in there, and I've just spotted something else there just as I kind of looked. There's another tube socket here, so it looks like this has twin rectifiers in it. I can see an EF86 at the back with a couple of damping rings on it, and then I can see another tube which I presume will be a 12AX7. So I think we'll get this out the case now and have a look, a bit more of a detailed look. I think, and boy, this amp is heavy, and the case is heavy as well, so a good amount of weight in that. We've got power transformer, choke, output transformer, more tubes at the back here, couldn't see those. What we got here, 12AX7, there again, that one. And same again, 12AX7 ECC83S they are actually. And then we've got the I'm sure that's an EF86. It will be. Can't really see it under the lights, but I think that is an EF86. We'll check anyway, but I'm pretty sure it is in there. Put that other 6B Q5 back in. So extra socket here. So this must be a twin rectifier. That's something we need to look at. I just took that rectifier tube out because I don't want to damage it. Right, let's have a look inside. Now the first thing I see in this is these Holy Grail capacitors. Now I ordered some of these from the States. They were like 50 plus 50 very slim capacitor, and I put those in a WEM Control 30, or one of them, and it failed after 12 months. One side of the cap, one half of it went open, and they were well under the voltage. I think they were rated for something like 450, 500 volts. I think we'd only got maybe 350 on there, but it failed. Having said that, the one I replaced it with has not come back so far, but it's still less than a year. It lasted a year. And I seem to remember something about these caps that Lyle Coleman mentioned about them on a video, and it's slipped my mind now. I'll have to see if I can find that again. Very, very well laid out, very tidy work. At a glance, a lot of wiring in there, but we've got this rotary switch, so that's going to create a lot of this wiring there. Very interesting. Tone control, that is where all those must be going. They are going onto this board, looks like it. So we're going to see if we can find a schematic for this amp. Really interesting. Where is that master volume? It is there. It says it's not wired up. Well, that looks wired up to me. So is that pot faulty? Is it damaged? Could well have had a knock, got broken. There's also it's push pull pot on there. I've just spotted that. Just there. So we need to look at that as well. Look at the date on the transformer. Let's just come in a bit closer. Let's get you in a bit closer. So 14th of June 2008 on the transformer. So this amp kit could be fairly old. Well, if that's the case, when it was built, the Holy Grails have lasted really well then. Maybe I just got a bad one. We have got some solder here stuck onto the capacitor, and that's just gone inside. We need to get that out. I want that floating around here, and there's some more on here, a splash of solder here. Let's have all that off. We don't want that on there. You just caught it with the soldering iron there as well, just burnt it slightly. We need to get that out. We'll get the I'm going to just put the hoover in it and just get that lot out. But lovely workmanship, lovely crowns on these. That's how I like to do them. How they've crowned all these turret boards. Really, really good work. That really nice soldering work. This amp's been really well put together. Really nice. Look at all these neatly folded wires here. And this on the rectifier, look on here, really nicely done. So I've got a couple of resistors here, and we've got a 62 ohm resistor now. I'm just looking where that's going. Is that? So that's wired off that blue wire there. That's going to this power switch at the back here. Is that a cathode bypass capacitor? Floating around a bit, mind you. 160 volts, 220 microfarad. Where's this wire going? Here. Is that going to ground? I think it might be. So where's that going? Where's this yellow wire going here then? So the only thing that's concerning me about these is these wires running underneath these resistors. The resistors are sat on them. That was to burn up. I don't know what that's actually doing, but if that was to burn up and burn through those wires, they're probably only on the tones. Actually, Now I kind of get the impression someone else has been in here working. So these splashes of solder that we see here, and look at this solder in here, there's a blob of solder on that. That is not the guy that's done this, is it? You know, the guy that's done this has made a very, very professional job. That there, you can see, is just not nice at all. Not been done properly. Bit of bird poo there. I certainly would. And this one again here, look, you can see this doesn't look right. Just coming a bit closer. We're getting too close with this, it goes out of focus. But yeah, so that to me says someone else has been in here. That resistor there has so looking round at the rest of it, and he said that it's as if somebody's changed the drop-in resistors just on these few caps here. Again, we've got carbon comp here, we've got metal oxide here, so it looks like somebody's been in here doing a bit of modding. But that to me doesn't say this, so I would guess someone's been in here doing a bit of modding on these drop-in resistors and things. And the other thing is, you can see these have got burnt. Whoever's been working around this area, where you look at everything else in here and it's just perfect. So yes, I think someone's been in here. It's not quite Billy Bodger, but it's certainly not far off. But it looks okay. It's just a bit untidy, and that blob of solder there, and you know where it's not. It looks to me like they've either not held the iron on long enough to get that to flow, or it's just not taken because this, you know, there's some there's some muck in there, oxidization, and the soda's not taken there. But we can have a look at that, sort that out. I'm quite impressed with this amp, full stop. It's excellent workmanship. Look at these wires, how beautifully how they've been wound here. Absolutely stunning work, really good. So if the guys from Ceriatone have built this amp, then I have to say, top drawer, gentlemen, very well done indeed. Certainly gives you a bar to aim at. So that's all looking pretty good, and I suppose everybody's itching to have a listen to this really, and I really need to plug it in and see what faults this amp has. It certainly has this this master volume is supposed to be not working. Right, I think we should get this plugged into an amp. Normally I'd put this on the oscilloscope, but I think I'm so itching to have a listen to it. But right, we were going to have a listen to this amp, and I didn't spot this under the lights, but these, you can see these light tubes have had some heat. Look, they're turning white on there. There's only one pair of them like that. I didn't actually see that when we was looking at it through the camera under the lights, but when I plugged this in, it was a little bit unstable, but only when it first powered up. So we need to get to the bottom of what's causing that. Right, so I think somebody's been in here testing at some time. This wire, you can see how short it is there. There's some wire going into there. There was another piece of wire that came out of there. So I don't know. This resistor's burnt all on the edge. We could see that before when we were looking at it. So I think we need to let's just test that resistor as well. That 22k. Let's see what we have. We do indeed. That's perfect, despite being a little bit charred by someone's soldering iron on the other end, and they are rather close to the terminal. So I suppose if they've been in with something really powerful, to be honest with you, must have been, because my 25 watt iron is struggling to melt these, and it doesn't normally. So, but you can see this strands of wire. There was, as I say, another piece of wire came out, as if there'd been another cable on here at some time, but obviously not. So we'll get that pot back in. You can see there on it now, you can see where it's been burnt. So someone's definitely been in here testing. You can see the soldering on there is not great. Right, so I've been testing a few things. I've replaced this and soldered it up properly. I've put a new resistor in there because that one had got all the end burnt on it. So we've put that in. It's a 3 watt instead of a 2 watt. And I've also moved it a bit further away from the terminal so it doesn't get burnt when the iron goes in. That one, even that one's a little burnt, but that's all done. That cap's fine, and I think those caps are going to be fine. So now I've turned my attention to the bias and why those tubes, those two tubes have been baked. So this high and low switch on the back, which is also faulty, probably wants cleaning, works by cutting out 2 of the tubes. So when it goes on to half power, these 2 tubes get cut out. Now, to compensate for that, they put another cathode resistor in series. We've got 2 here, a 68 and a 62. And how that works on this switch is that when you switch it to half power, the cathode, it disconnects the cathodes of these 2 tubes, and so therefore they just shut down, and these are going to be taking twice the current. So what they've done now, but to compensate for that, is they've added another resistor in series, and so we get 121 ohms we get on half power to compensate. Now that may be why these tubes are baked. Maybe they're getting a lot of voltage, and we're going to have to test that. So that's the next thing I'm going to do. So I had a 315 plate to cathode, 315 volts plate to cathode, and the tubes were biased at 12.5 watts. That's for all 4 of them. Now I've got this on the dummy load now, and it's on the oscilloscope. Now that's on half power, that's on full power. The switch is working again now. So let's get this, try and get this meter in shot if we can, so you can see a little more of what's going on. So you can see the meter there. So we're on high power. And if I go to pin 7 there, got 313. Let's see what happens when we drop this. Not a lot. So on the wall meter, when we flick it in high, we're now using 111 watts with 520 milliamps. If I drop that, we now go to 380 milliamps. So we're clearly only using 2 tubes now. So 315 volts, 337, 339 volts now we've gone up to there. So 339 volts, but now we've only got 2 tubes. 339 volts, plate to cathode. So what's the drop across the cathode resistors? That's going to be, let's have a look. Where are we going to test from those to ground? See where, so they're connected together at that end. Yep, so we lose cathode voltage on the high there on that side. That's when that resistor is disconnected. If we go to the grey wire which goes to those resistors, you can see Oh. What's happened now? There we go. So now I've got 5.8 volts. So 5.8. Now I've got 121 ohms. That gives us 47 milliamps. Divide that by 2, gives us 23, and then we times that by 339. That's 8 watts each, according to that. We haven't taken 5% off for the screen, so I don't know. I don't know what's going on there. Right, so I made a hash up of that second bias reading. I, like an idiot, I measured across one of the resistors, and what I should have measured from was from blue here to ground here, which is taking them both. Now that's given me a volts drop of just over 12 volts, and I've just done the bias, and those two tubes are a whopping 15.9 watts, 16 watts, and that's why they are suffering from that, the paint going white on them. They're just being thrapes. These JJs won't stand that for long. Got that engrossed in it, and then just realized that I'd measured the resistance of the two resistors in series, but I didn't measure the volts drop in series. And in actual fact, this blue wire here from the switch is switched in when it's switched to half power, and that blue wire goes down to here on this resistor, and then that goes through that resistor. They're connected together there, comes through this resistor, and then goes off to ground. This green wire is ground. But when that switch is switched up, that disconnects the blue wire and connects the grey wire, which then just connects to this resistor and goes to ground. And this resistor then is redundant because it's not connected anywhere on this side. And that's how it works. That's where I made a mistake. I'd measured across one. I should have measured across them both, and measured from, so you measure from blue to ground on there. So now we know why those resistors are, those tubes are getting baked, and baked they are 16 watts. I thought when that came out at 8 watts, I thought that's not right. So I went back and just studied it again, and I entered a break for a while. So I'm getting a bit tired and ready for me tea, ready for food. So, but yeah, we've got there in the end. Don't get it right every time, the maths, but we got it right in the end. Now I've sprayed some contact cleaner into that switch, and that does seem to be okay. So when you switch to half power, but this is the strangest thing with this now. I don't understand why those two tubes are baked. Because when this is switched out, the outer two tubes are disconnected. Is that right? Yes, because this set of cathodes, the inner two, and that's the inner two. So why have we got two tubes? So has somebody moved one of these tubes from a position? Has someone had these tubes out, put them back? That's probably what's happened there. And then one of those tubes that's been here has got put into this outer one here. That seems to make more sense, because this here on the center of this switch is connected to these cathodes, and this orange wire connects to that other tube there. So those set of cathodes are connected together. The wire on the bottom that you can see there, that red wire there, you can probably see it, that's connected to this cathode and this cathode. So when that switch is switched up, it switches these two out of circuit, the outer two, and only the inner two run. Right, I've got this amp on the 4x12, and the customer doesn't want to go too mad with this amp, because he doesn't use it very often. He's got quite a collection of amps. He only uses this amp occasionally. So we're not going to mess around with that bias and try and balance it up better. He's just going to use it on the high setting. He doesn't use it on the low anyway, so obviously the person that had it before him has been using it on the low, hence why the tubes have got baked. So a bit of a design flaw there. Now let's move on. So we're on this first channel. So the first thing we notice about this amp is it's very bright. The tone controls are a bit strange on it. So when you turn the treble full in, it's like the mid's been turned out and all the bass. See that? So that's a bit strange. When you turn the bass full, it mutes the treble. See that? Explain that one. So there's some very strange things going off with that. So we've got the master volume on there. Let's just have a bit of a listen. Let's flick the master volume out. This thing is monstrously loud. Boy, that is bright. The other thing is that if we pull the master volume, it doesn't quite cut out completely, and as we bring this up, you can hear now the master volume's down, so that's not wired up correctly. Now I don't know whether that's a fault of this amp design or whether somebody's been in here modding it. We do know someone's been in here. So let's just bring this master up. This master has quite a bit of travel. Just kicks in. And if you push that in by mistake, then that's the amp flat out, which is what I've just done. So and that's just made Pink gulp a few times. She's down there on the floor. She wasn't impressed with that, and she's bailing. That's me in the doghouse for the day. That treble control is very weird. treble and mid combined. The problem is you can't wind the top off it and it's extremely bright. So that's a bit of a flaw in that. Let's try the other channel. Now this tone control is a rotary switch. So let's start on the bottom one. Wow, that is loud. My days. That's just wow. That's as loud as a 50-watt Marshall. In fact, louder. Let's pull out the master. Push the master back in. Let's try the cut. So you can get a reasonably warm tone with that. Turn it the other way. There's not really a lot of difference in those. There is between the first one and the last one, but the rest of them are all pretty much the same. So let's crank it then and just see how much gain this channel's got and what that gain's like. Whoa! Put the master volume in there. Oh, this thing is blisteringly loud. like the overdrive very much on that channel. But that is seriously loud. You only have to touch the control on that, and Pink's glaring at me now. She's not impressed with that. That sounds really nice, and I think this amp really is, you know, it's a blues player's amp. You know, crank it up, it's loud, get it to clip. Let's just put it on the other setting. So that's half power. It's still incredibly loud though. Really fat tone. That's yeah, so nice clean tone. Not so keen on the really overdriven tones, and I don't think this amp's really made for that. Tone network on this is a very strange. This channel's okay, you can get a nice warm sound out of it. This one you just can't. It's very bright and a little harsh for me, that channel. But the amp's up and running again now, so we've got cured the problems it had. Only small problems really on this one. So that'll do it for this one. So it's been a bit of a strange one, this, hasn't it, really? A bit weird. We've got a Ceriatone amp kit in a Matchless cabinet. So very weird. But that'll do it for this one. So thanks for watching. You all take care. See you all in the next video. Bye bye for now.